All right, hey cuties. We're going to design our own lab today. And I just wanted to give you kind of some ideas about how to do this procedure. You should be able to do it independently. You're more than welcome to work with a friend if you know somebody in class or in my other class. You're welcome to share ideas with them, but everybody's going to be turning in their own results and their own experiments. So the idea here is that you're going to try to show what impact dissolving substances in water has on the surface tension of water. And you're going to do that by adding drops of water to a penny. And if you have a dropper, that's ideal. But otherwise, you're going to have to figure out how to add drops of water on your own, whether you drop them from your finger or whether you drop them from a pencil or whether you drop them. You figure out how to add those drops of water to a penny. And you simply count how many drops of water you can add to the penny before it spills over the edge. Then you're going to experiment with different substances that you happen to have at home that you can dissolve or add to the water, and then count those numbers again. So how many drops does it take now that you've dissolved something? How did that impact the surface tension of the water? I want you to do 3 trials, and I want you to have at least 3 variables. So meaning you'll do just water 3 times, you'll do another variable 3 times, and you'll do another variable 3 times. If you want to do more because you're interested, that's wonderful, but you don't have to. You would not need to. So just looking at this document I have here, the overview: determine how many drops can fit on a penny, complete 3 trials for each of the independent variables. Write a procedure. I just started by typing in some numbers for you, but just make sure your procedure is in number format. You never write a procedure in paragraph format. Not in a science lab, you don't. Okay, and then tell me your independent variable, your dependent variable. What are some constants that you need to maintain during this lab, or that you're going to try to maintain during this lab? And what's your control group? I want you to show me some photos. So I don't, it doesn't need to be real specific, but maybe show me a photo of you adding the drops. Show me a photo of your penny with some water on it. Show me a photo of your ingredients. I don't care. Just show me some photos that show that you're actually doing this experiment at home. Then design your own data table. And of course, you can insert. So just to show you that really quickly, so you can insert and then table, and you decide how many rows and columns you need. The suggestion I always make for everybody when we're doing this is always have a row across the top for labels. Look at the data table I have on the screen right now. Always have a row across the top for labels, and always have a row on the side for labels, and then calculate how many rows and columns that you need to add your table. So that's just for the data itself that you're going to collect. How many there we go. How many drops of water can you add to the penny? And I do want you to add an area for the mean. So what's the average? So you've calculated it 3 times. What's the average number of drops that you were able to calculate? So that should be in data table number 1. Then you're going to need to add a graph, and I'm going to go over that in just a second. And then finally, data table number 2, you're going to calculate standard deviation and standard error of the mean. And we're going to use your answer here to then draw, and we can't use the graphing program on this. It's not good enough. You're going to have to hand draw error bars. And that's tricky to hand draw something when you're actually working on a document. So I want you to play around and figure out, when you're all done with this, can you convert it into a PDF and then draw on it with Cami? Or can you take a screenshot of it and draw on it? You figure it out, but you need to draw error bars on your graph. That's a huge part of making this an AP Bio lab and not just a regular junior high level lab. Okay, and then just a couple things to remind you about standard deviation and standard error. Basically, I'm not too worried that you know the difference between them. You will be given these equations through AP Biology on an equation sheet. So you'll be expected to be able to do this math on the AP exam, but they give you the equations, just like I'm giving you the equations. The basic idea is that standard error, scientists have agreed and statisticians have agreed that when you draw the error bars, you make them plus or minus 2 times SE sub x. So for example, if the number that you calculate here is 1, a plus or minus 2 would be multiplying it by a positive 2 and multiplying it by a minus 2. So that means your error bar would be 2 above your normal bar, the bar in your bar graph. I wish there were two different words for that, not bar and bar. Anyway, so you'd have 2 above and you would have 2 below. So that's plus or minus 2 SE sub x. Your SE sub x in my example was 1. And then you look to see if the error bars overlap with the other bars in your bar graph. How about the other columns in your bar graph? That'll be my new word. If they overlap, if they intersect, then we say, because of random variability, we can't really say the differences in your columns are significant. However, if the error bars don't overlap, then we can say, hey, there's a significant difference here between your water, your plain water versus your substance that was dissolved in it. So then I'm going to have you write a 1-paragraph conclusion, and there are things that I want you to say in it. I want you to tell me about your variables and the biochemical nature of your dissolved substances. If you don't know it, look it up online. So for example, if you dissolve salt in water, that's an ionic substance. I want to know that. I want you to tell me that. If you dissolve sugar, find out what that is. Find out what kind of sugar you're dissolving, and then dissolve it. If you want to use oil, if you want to use artificial sugar, I don't care, just find out what that substance is. And then you're going to tell us whether it significantly impacted the surface tension. And you know if it significantly impacted the surface tension by the error bars that you hand drew in. All right, and then finally, you're just going to succinctly answer the question. Remember, this is just a paragraph. I'm not asking you to write pages. You're just succinctly going to answer the question, what impacts the surface tension of the water? And you need to have evidence from what you found in your table, in your experiment. So don't tell me other things that impact the surface tension of water. Just tell me in your experiment what impacts the surface tension of water. Maybe nothing was significant, and you're going to say that, and you're going to support that with your evidence. So you just have to have evidence to support that claim. Okay, so the one thing I wanted to show you really quickly, however, was just to remind you how to do a graph. So I'm going to go right here. I'm not going to add the graph this time because then there's always ownership issues, like KJ owns the graph and then you guys can't edit it. So I'm just going to remind you how to do it, and then I'm going to delete it. So in this case, you're going to insert chart, and you're going to add a column graph. That's what they call this one, is a column graph. So we're going to go ahead and insert it. It opens up, if you didn't notice on the tabs here, it opened up an Excel, not an Excel spreadsheet, a Google Sheets tab. And it has a fake data table in here. Sorry, not data table, fake graph in here. And the data table, to get to it, so I'm going to click on this, and I'm going to open this little icon in the corner. It's a little menu in the corner, and I'm going to click open source. Now it opens the tab. I guess it hadn't already opened the tab. Anyway, give it just a second. It says it's working. It'll take a moment, and it's going to add this chart that has nothing to do with our data. It's just a fake chart that they give you to kind of get you started. And it's still thinking. This is where you speed up my video so that it gets to the part that's working. I have no idea what's taking so long. There we go. What's annoying about this is that they always shove the graph into the corner and you can't actually see the data table. So I'm going to just scroll, do a little for me, it's a 2-finger scroll, so that I've gone down and over to the side a little bit so that I can see their data table. Now we're only going to have one, they have 2 periods. We're just going to, and this is about points being scored. None of this is applicable, but we're going to do the mean of the number of drops. So mean number of drops, that's going to be my 1 column. And then I'm going to have my 3 variables, maybe water, and then whatever your first and second variable are. So variable 2, or 1, I don't know what you want to call it. Put in the right words. I'm making a rough draft for you. Variable 2, whatever, who cares? And then we won't have this third one unless you decide you want to try another variable, and you are certainly welcome to try another variable. For this next column, we're not using a second column, so I'm just I highlighted it and then I hit delete, and now I've got my 3 columns. However, there are still problems. It says this is points scored, and it doesn't tell me, it doesn't label the axes. So this is where we again go into the right-hand corner. This time it looks like 3 dots. We click on that and click Edit Chart, and it should pop up over here on the right. And we're going to click Customize. I don't think there's anything in there right now. So the first thing that we're going to do is change the title. So change the title to an appropriate title for the experiment that you're doing. And then I was trying to think, oh, and you need to change the axes and everything. Let me get my picture out of the way here. So I think if you scroll down, no. Oh, I know. It's a menu right here. So it's a drop-down menu. So where it says chart title, you can change the chart title, but now you can change the horizontal axis title and the vertical axis title. So be sure that you label both of the axes. Absolutely going to be checking for titles and labels on both axes. And I think that's it. So the part that I don't want you to get fooled by, if you go to series and scroll down on series, it says error bars. And these error bars suck. I cannot figure out a way to make them work the way we would want them to work. So ideally, you would do something like standard deviation and then tell them a value for each column. But look at these error bars. It works for this one, but it doesn't work for this one at all, and it doesn't work for this one at all. So these error bars are not correct. You could even try something like constant, but then like your error bars are not constant. Your error bars are going to vary for each one of your columns. So this just, it doesn't work. So ignore the error bars. Do not put error bars in digitally. You're going to have to hand draw those error bars in, and that's going to be a little bit complicated. All right, and then when you're all done, if you just go back to the original tab where you were and you hit update, it should update your table for you. So your chart should be all done, except that you need to add your error bars. Please let me know if you have any questions. I think that's it. All right. Have a good night.